All right, now, some of you guys are Sketchpad users, some of you guys are document users. If you're a Sketchpad user, I'm sorry for you, you're going to struggle, okay? If you're a document user, you'll be just fine, okay? Because we're a document. Today is a document type of a day. So you are going to, number one, open a new document. You can either use the arrow keys to go over, or you can just simply hit the number 1, and it will go to this screen then. Okay? Now, on the white sheet, okay, on the white sheet that I have, it's the lacrosse players sold raffle tickets for their annual fundraiser for 6 weeks. Okay? The table of values is a record of how many tickets were sold each week. So there's our table of values. Okay? What we want to do there is we want to create a scatter plot of that data. Okay? Now, the back side of the white sheet is the notes that we gave you at the beginning of the year on how to create a scatter plot. Okay? So we're going to quickly walk through those because we've seen them all before. Okay? So we're going to quickly go through those. Again, need a graphing calculator too. Okay? All right? And we're going to create ourselves a scatter plot of that data. Okay? All right? So we're going to use the data and statistics scatter plot, but in order to use the data and statistics scatter plot, we have to first create a list and a spreadsheet. So you want to go to number 3, lists and spreadsheets. Now, when we're in there, you're going to scroll up to the top of your column. It's too far. You're going to scroll up to the top of your column, and the top of your column is going to need to have a title. Okay? I wouldn't go, it's got to be one word, okay? No spaces. It's got to be short. I got one up here for you. Okay? It's got to be short, okay, and sweet, and you'll see why it needs to be short and sweet for later on. So if I'm looking at weeks, right, okay, I don't even want to go with weeks. Weeks, one word, not too bad. I'm just going to go with W. Okay? That's what I'm going to title that column, and then I'm going to fill in that column. So then it is 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. Okay? So I filled in 1, 2, 3, 4, 5, and 6 in that column. Okay? Now I'm going over to column B, and at the top, again, I have to label it. So the label is tickets. So the shorthand of tickets would be T. Let's go with T there for tickets. Okay? Then you're going to fill those in, making sure that they correspond. So 1 corresponds with 25. 2 corresponds with 90. 3 corresponds with 100. 4 corresponds with 120. 5 with 135. And 6 with 147. Now, the kicker is you have to hit enter after you do that 147, or it's not going to recognize that data point. Okay? So has everybody got all of their data entered? Yes? Okay? Now, in order to make the scatter plot, okay, which you will then recreate up here in the little corner, little one, okay, what you're going to do is you're going to hit Control Doc. What that does is that creates a new page, and your new page is going to be Data and Statistics, number 5. Now, that should give you a mumble-jumbled, hodgepodge 6 points, because we have 6 data points, so you should see 1, 2, 3, 4, 5, 6 data points in there. We need to organize that into to something nice and pretty. Okay? All right? So, what do you think we're going to use as our horizontal axes? Weeks or tickets? Which one? Which one is independent? The weeks is independent, right? Okay? So weeks would go down here. But now, so you click in this click to add variable, weeks was W. So it takes it and it organizes it in one dimension. We're a two-dimensional type of a graph. So let's click over here, and if that one's weeks, then the vertical axis has to be tickets. Okay? So I'm going to give you a couple of seconds now to recreate that scatter plot on this graph on your paper. Make sure that you label your axes. The question was just asked, do we have to connect the dots? No, do not connect the dots. Scatter plots are not connected. Scatter plots are just that. They're points that are scattered amongst the graph. Okay? What we're going to do next is we're going to make a prediction equation. Now in math we call prediction equations regression equations. Okay? So there's my scatter plot. Okay? So now we're going to use the data and statistics page to also give us some regression equations. So I'm taking my data, which I have right there, and I'm going to make first a linear regression. So what they're going to do, what the calculator is going to do for me, is it's going to put a line that best fits this data right over the top of my data. Okay? So in order to do that, we go into menu. Oops, tap the brakes. I got to get rid of that first, and then I got to go menu. Okay? Analyze. Regression. And then I get all of my choices here for a regression equation. We want to do linear. We're MX plus B type of people. So there is my linear regression on top of my data. Okay? So that was part A. We performed a linear regression on the data. Visually, how well do you think that it fits? Visually, how well does it fit our data? It really, I mean, it goes through a couple of points. Yeah. You know, it's close here. It goes through that one. It's close to that one, so it's not bad. It's far off the other three, though, right? So it's not bad. Okay. Logically, does a linear regression make sense for this problem? Because what is this overall problem? We're doing what? How many tickets are being sold, right? So does it make sense that every week more and more and more and more and more tickets are going to be sold? Yeah, but probably only to a point, right? Because eventually you're either going to run out of tickets, the raffle's going to end, or you're going to run out of people to sell those tickets to, right? So to a point, it works. Okay? Let's now go through and perform quadratic regression on the data. You can leave yours right on there too. It's fine. I'm just clearing it off to make it so that we can see it. Okay? So, what were my steps again? Menu, analyze, regression, but this time I want to pick, which is number 4, show quadratic. Visually, how does that one appear? Better? Worse? Really good? Talk to me. Better? We're closer on more points. We're only really off on the 1. Okay? Yeah? Okay. All right. What I'd like you to do now is I'd like you to perform the cubic regression on that data. So there's the cubic. What do we think about the cubic? So far it's the best. Oops, this page. Okay. So of the 3, the cubic is the best. Okay. Does it make sense? Though cubically, logically I should say, not cubically. Logically, does it make sense? Explain to me, kind of.
Well, it has it that the line will be increasing, but we don't know that because we're reaching a certain point. Well, with like the quadratic one, it reaches a point and then it decreases.
So there could be, like, logically, we could increase in sales because everybody's, oh, excited, yay, raffle, and then sales kind of lag a little bit, but then they pick back up again because, oh, we're getting close to the end, let's get some more raffle tickets, as many raffle tickets sold as we can. Okay, I could see that. Yep, that works for me. Okay, all right. So that's creating a scatter plot and then using the regression aspect of the calculator to model your data. And that's what we're going to be doing these next few days, is we're going to be using the calculator to predict that, because that's what a regression equation truly is a prediction equation. Okay? So, now it says, if we want to compare mathematically how well each type, quote-unquote, fits the data, we look for something called the coefficient of determination. Now, if you're really into statistics and you want to take statistics at your next step, you'll go into coefficients of determination hardcore. Okay? And they'll even explain to you why the symbol for coefficients of determination is r squared. Okay? And it's capital R squared. Don't ask me why. Because even on some of the calculators, it's little r squared. It's crazy. Okay? Now, the kicker here, though, is you want, let's see, I can go like this, and I can go like this, and I can go highlighter, and I can say that you want the closer r squared is to 1, the greater the strength between the data. So the better it is. So you want that coefficient of determination to be as close to 1 as possible. That's what you want. Okay? The farther you are away from 1, the weaker the data is. So if we go back and we look at this, because we're actually going to find these now, if we predict them I would predict, based off of the visual models here, I would predict that the cubic regression is going to have the value closest to 1. I would say that the quadratic should be fairly close to 1, and I would predict that the linear is going to be somewhat farther away from 1 than what we would want. Would you agree with that? Okay. Visually, the cubic hits the majority of the points. It fits our data the best, so it should be closest to 1. Quadratic, close. We said it was better. Okay. And then linear was farther away. So, let's use the calculators now to do that. Okay? So, what you're going to do is you are going to go into Control Doc again. You're going to create yourself a new page. And that new page is going to be a calculator this time. We find the regression stuff in the calculator. Okay? So, we're going to go Menu, Statistics, Stat Calculations, and then here now we're going to do our linear mx plus b regression again, which is number 3. Now, on all of these, this pop-up window will come up. And this is why earlier I said you want to go as short as possible. Because the more and the more that you do this stuff and the more data you have in here, you're going to have more and more things to search through in here. Because we went with 1 letter on these, we don't need to even go in and search that list. We can simply just type in on our x's, according to our scatter plot, our horizontal asymptote was, or our horizontal axis, not wrong A word, was W. So we can just type W. By the way, Miss Randall, ladies and gentlemen, let's give her a round of applause. Give it back every time I walk into her room, she makes a clap for me. So, okay? And then our y's was what? Was T. So we can just hit Tab and hit T, and we don't even have to search anything. Now, the other cool thing about this that we'll get in more tomorrow is that it's going to save that regression equation, this equation that it came up with back here. This regression equation, and I find my, so many things. This regression equation right here, it's going to save it. When you're in data and statistics, it won't save it. Okay? It just uses it for there. But this now is going to save it in function 1 so that we can use it for predictions. Okay? So when we hit enter here, or hit OK, there is our linear regression equation. Okay? So let me move that over onto here. So this is telling me that this is my linear regression, and it's telling me that it's got an R squared value of 0.89. Excuse me, 0.879. Which in the statistical world is not good. Just so you know. Okay? It's close to 1 mathematically, but in the statistical world, it's nowhere near 1. Okay? All right? So, let's now perform the quadratic regression menu, statistics, stat calculations. This time I'm going to choose number 6, quadratic regression. Again, I'm going to pick W as my X's, T as my Y's. Now, if I would have to use this later on, it would be saved in F sub 2. So I kind of make a mental note, maybe a jot on the side of my paper saying this one's saved in F sub 2. Okay? But again, we'll get more into that tomorrow. Okay? So there is my quadratic regression. And it gave me an R squared value of what? 0.954. Better or worse? Better, right? And we had predicted that that one should be closer to 1. Correct? Okay. You now find me the R squared value for the cubic regression. Menu, statistics, stats, cubic, W, tab, T. Scroll, extend, paste. So this is my cubic. It says so right there. Oops, this should have been green. This is my cubic, and it's got an R squared value of 0.981, which is the best one of the 3. Okay? What? Quick calculate, see what it says.
Oh, you already did.
Oh, what you got? 0.996. Okay? And you're going to find that the higher you go in terms of degree, the better it fits. Because there's more of these, here's the equation right here. This is the equation. So there's more of these extra terms the higher your degree gets, which allows for that little tinkering and the adjustments of that function. So, because it has more terms in that, exactly. Now, logically though, Austin, it might not be logical to use a quintic, which is a degree of 5, a quintic function on something like that. You know what I mean? So we'll actually have you think about these problems too as we go along. Which one is best? Obviously, the higher you go, that one's going to be better. But logically, which one makes more sense? Okay? Because, like in the last class, I said I threw a ball. I used the toilet paper roll as my ball. Okay? I threw it. It should make this. It should make an arc, right? Which is a quadratic relation. But if I only do a little brief snippet of it, the cubic would probably fit in there better, but logically the cubic doesn't fit. Okay? Alright? In your textbooks now, which regression appears to be best, we said cubic. Okay? Page 415 in your textbook now. We're going to become urban planners today. Okay? Transportation plans are an essential part of any large urban development project. State of Wisconsin does this all the time with infrastructure plans. They did a huge one about 20 years ago right here in Wausau when they decided to put a third lane on Highway 51. Okay? They studied traffic patterns and they studied all this different stuff.
Who hole punched this? Yeah.
My secretary.
I made my own hole.
Yeah. Don't worry, I noticed it too right afterwards. It was 3-hole punch, but she only 2-hole punched it. Happens. Okay? You know what? Best part is, I'm over it already. Because there's a 3-hole punch up there, there's a 3-hole punch on my cart, and there's a 3-hole punch in many places. Okay? Yep. Okay? So, what we're going to be looking at here now is on page 416, problem number 1. City planners are considering building a new stadium on several acres of land close to the downtown of a large city. They monitored the number of cars entering and exiting downtown from a major highway between 1 p.m. and 7 p.m. to determine current traffic conditions. So, what I would like you and your shoulder partner to do now is I would like you to do number 1, 2, and 3, which is pages 416 and 417. Okay? All right? Go. All right. Question 1, part A. Describe any patterns that you notice. This is what your scatter plot should have looked like. Where on the bottom you have the time. And on the side you have the vehicles. And those, remember, are in thousands. Okay? So, what patterns can you see? Remembering the scenario of the problem, too.
Not as many cars were sold after.
Not sold,
Or where?
traveling, right?
Yeah,
Okay.
that's what I-
So it seems to be at about 5 o'clock, less cars are on the road, right? Okay, that's a good observation.
It's usually
Did you say cloud be like rush hour and then after that it dies down?
Or dies, so instead of saying it slows, it dies down. Okay, all right. So traffic. Whoa, tap the brakes. Traffic builds until about 5 o'clock, comma, then lessons, let's say. Does that make sense? Why does that make sense? Somebody explain that to me. Max, go ahead.
Because like people have work and stuff and they're going home and then after that point the roads won't be as busy.
Because we're talking about downtown, right? A lot of people live downtown.
No, people work.
A lot of people work downtown. Not a lot of people live downtown in a big urban setting. Okay? Not a lot of people live downtown. They live in the suburbs, right? Okay? But they work downtown. Okay? So in this time frame up here, okay, we've got work. You've got people coming and going. You've got, what else do you got? School, yeah. Shopping. All that stuff, right? Then during this time, it's after rush hour, right? So most people are already back home or school's done with or, you know, all that stuff. Now, we're talking about building a stadium, correct? Okay. So might there be another spike at like 7 o'clock for some people coming to whatever sporting event it is? Okay. Now, in the last class we did this. What if we took this as a whole day? So here's midnight at the end of the day. Here's midnight at the beginning of the day. What should the traffic pattern look like?
It should just keep on going like up and down.
So like, what do you mean?
Like from 6:30 to 7:30, it should be really high.
So it should be relatively low. Let me go in a different color so we can actually see it. We'll go in green. Okay. So it should be low, right? And then it would get high as the morning rush hour comes in, right? And then it's going to kind of level off because everybody's at work and at school. Okay. Get high around lunch, but probably not as high, right? Okay. And then it'll go back down.
And then just
And then what we have, right? And then we might have that little bump if there's something like that. So the snippet that we have is kind of right in there, right? So if we just look at that little snippet, that to me would be quadratic, right? If we look at the entire day, that to me might be quartic, because it would have, because it would have the two humps then, right? Okay. Higher level in me says it's sinusoidal, but that's pre-calcish. Okay. So our prediction here would be quadratic. Okay. So then in number 2, you were actually supposed to actually make the whole thing. I suppose I could have just used the one that was over on the side, but oh well. Okay. Recall that a regression equation is a function. So let me move this over a little bit. Okay. So we need to figure out all the different ones for this one, right? Which you should have done. So this is the linear regression equation off of our data, and it's got an R squared value of 0.18. Do we like the linear regression for this one? I don't even know if I could say that it's bad. Okay? Because remember, we want to be close to 1. So it's 18% good. Is there anything where 18% is good? If I won the lottery 18% of the time, I'd be okay. Right? What? Percent of error? You don't even know like 18% error, you know what I mean? Okay? So this linear function here would have been, or this regression equation would have been 1.24x plus 10.21. And again, it's only at 0.18. Okay? Quadratic then which was our prediction, right? Okay. Our prediction of quadratic had an R squared value of 0.834. Right? So that function would have been y equals negative 1.36x squared plus 12.16x minus 6.16. Not bad. Okay? But the cubic move my okay. The cubic has an R squared value of 0.98. That's pretty good. Okay? So this would be y equals negative 0.41 x cubed plus 3.50 x squared minus 4.47 x plus 8.44. Okay? That would be our prediction equation starting with tomorrow. Okay? Because that's what we're going to do tomorrow, is we're going to take that one, because that one we decided was the best, and we're going to use that to predict, okay? We're going to use that to predict when downtown is congested, okay? When it's less traffic, when it's how many vehicles will be there at noon, 9 p.m., okay? Midnight the previous evening, okay? So we'll use that to predict all that stuff, and sometimes our predictions will be right, sometimes our predictions will be a little off base, because really should we be using a quadratic or a cubic on this one? You know, we said quartic maybe, you know? So it all depends on which one we decide to use, okay? You got a green homework today that you need a graphing calculator for. You got a yellow homework yesterday that you need a graphing calculator for. Okay? Both of those, because of the added component of the graphing calculator, both of those homeworks will be due on Friday. Okay? Yellow and green will be due on Friday.